So before we continue with solving quadratic equations, we have to introduce a new concept here, and it is the imaginary number. So an imaginary number is quite simply a number that does not exist, and it all starts with the number I. What I mean is it cannot exist mathematically. I equals the square root of -1. And if you think about it, there is no square root of -1. There is no number that will multiply by itself to give us -1. But just because it's impossible doesn't mean it still can't be used in math. So imaginary numbers are all based off of I, the square root of negative. Here's the way we can use I. What if we have I squared? Well, the square root of -1 squared, when you square a square root, it just disappears. They cancel each other out, and you're left with -1. So now we have I squared is a real number. What if we kept going up? I cubed. Well, we're just going to multiply I squared by I again. Every time we increase the exponent by 1, we just multiply it by itself again. So this will be I times I squared, which is -1. So we'll have -I. What about I to the 4th? We multiply I cubed by I again, so we'll have -I times I, and this will be -I squared. Now we know that I squared is -1, so -1 is going to be just 1. So why are we doing this? Well, if we keep going, you'll see in just a second. I to the 5th, that's going to be I to the 4th times I, so 1 times I is I. I to the 6th, I times I is I squared, so that's -1. I to the 7th, -1 times I is -I. And I to the 8th, -I times I is -I squared. -1 is +1. So if that sounded a little bit familiar, well, look back up here. I to the 5th equals I to the 6th is the same as I to the 2nd. I to the 7th is the same as I to the 3rd. And I to the 8th is the same as I to the 4th. So what we actually have here is a repeating pattern. Every time we go through 4 rounds of increasing the exponents, the pattern just repeats. So I to the 5th, the 9th, the 13th, it's all equal to I. I to the 6th, the 10th, the 14th is all equal to -1, and so on. So what can we do with this? Well, since we know it's a repeating pattern, now we can easily calculate something like, let's say, I to the 11th. I to the 11th. Well, let's just keep going with this pattern. I to the 5th, 6th, 7th, 8th. The 9th is going to go back up to 5, so it will be I to the 9th, I to the 10th, I to the 11th. I to the 11th is the same as I to the 7th, so it's going to be -I. How about I to the 18th? Well, we'll just keep going in the pattern. We have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I to the 18th will be -1. Now, we start getting higher numbers like I to the 43. There is a faster way to do this than having to keep counting through the pattern all the time. We're going to do some division. So since the pattern repeats every 4 exponents, we're going to divide 43 by 4. And this is going to show us the number of times that the pattern repeats. Because we are going through 43 exponents, and it repeats every 4. So 43 divided by 4 is going to be 10, and we're going to use remainders here. So 10 remainder 3. So what this shows us is we go through 10 complete cycles of the pattern, and then we go 3 more. So after 10 complete cycles, we'll be at the bottom of the pattern here, starting back up at the top. So then remainder 1, remainder 2, remainder 3. Remainder 3 means the third number in this pattern, so it will be negative I. Now we could even do something really high, like I to the 229. Again, all we have to do is some simple long division. So let's do it. 4 goes into 22 5 times. Subtract that. Bring down the 9. It goes into 29 7 times. And we're left with 57 remainder 1. So that means that we go through the entire thing 57 times. And so we're at the end here. But then we go one more term. And so we're back at the first term in the pattern. I to the 229th equals I. Okay, let's do one last more problem. I to the 184. So we're going to just do 184 divided by 4. Do the long division here. And we're left with no remainder, just 46. That means we go through the whole pattern 46 times, and then we stop at the end of the pattern. So the last term in this pattern is going to be 1. So I to the 184 is 1. Okay, so that is just one of the many things you can do with this imaginary number I. The next thing we're going to work on is just regular operations with I. So what we're going to do is just add or subtract it like any other variable. So this will very simply be 3i plus 6i is 9i, and 2 minus 5 is 3. So 9i minus 3. Pretty simple. Again, just a simple adding algebraic expressions problem. Negative 5i minus 7i will be negative 12i. And 4 minus negative 12 will be 4 plus 12, which is 16. Just be careful here because the I and the number are in different spots in both of these parentheses. So you want to watch that. Okay, let's move on to multiplication. Again, there's nothing really new here. I times I is I squared. I times 3 is 3i. The only thing you want to remember to do is if you're left with I to an exponent, you can simplify that. I squared, as we proved over here, is negative 1. So this will be 3i minus 1. More expanding here. 6i times 4i is 24i squared. Plus 6i minus 12i will be minus 6i minus 3. And remember, once again, to simplify the I squared. So 24 times negative 1 will be negative 24 minus 3 will make negative 27. So this will be negative 6i minus 27. Okay, and one more multiplication problem. Little more complex here, so we're going to have to do a few steps worth of simplifying. Okay, first, let's just distribute everything outside the parentheses. So this will be negative 3 plus 7i plus 21i plus 28i. You had a lot of double negatives, so everything here turned positive. Sorry, this should be 28i squared. Okay. So 28i squared is going to be negative 28 because of the I squared turning to negative 1. So we have 7i plus 21i is 28i, and then negative 3 plus negative 28 will be minus 31. Okay. So there is multiplication. We are going to get through all these operations in one video. Next up, we did addition, subtraction, multiplication. Now let's do division. So 2i plus 4 over 6. The only thing we can do here is what we did in the last video, where since everything is divisible by 2, that's exactly what we're going to do. Divide everything by 2. We got I plus 2 over 3. Okay, now this one is going to be a little more complicated. How are we going to simplify this? Well, what we need to do is eliminate the I in the denominator. Just like when you have a square root in the denominator, like in the last video, you want to rationalize the whole thing by multiplying by that square root. We're going to be doing a similar thing here. We're not going to multiply by the denominator necessarily, but we want a way to eliminate the I term. So let's think about this. Just focus on the denominator for the second. If we were to square the denominator, meaning multiply the numerator and denominator by what's in the denominator, 3i times 3i would be 9i squared. Then we'd have plus some i's, and then plus 4. So the only problem here is that we haven't gotten rid of the i's. Getting the I squares is good because those just change to negative 1. So how can we get rid of the i's? Well, what if we change this to 3i minus 2? 3i plus 2 times 3i minus 2. Now we have, this is negative 6i and positive 6i. So those cancel out, and we'll be left with no i's. So what we actually did here is called multiplying by the conjugate. This 3i minus 2 is the conjugate of 3i plus 2. The conjugate is just the same expression here, where you have some i's plus a number, except the number, you change the sign of the number so that the i's will disappear. So what we did is we multiplied this denominator by 3i minus 2. So we're going to do the same for the numerator now. Multiply it by 3i minus 2. And now we have some simplifying to do. This will be 30i squared minus 12i minus 15i, so that's minus 27i plus 10. Over here we have 9i squared minus 6i plus 6i, so that worked. The i's are gone. Minus 4. Now we're still left with some I squared, so we want to eliminate those. So 30i squared will be negative 30. Add that to the 10, and we'll be left with on top negative 27i minus 30 plus 10, so minus 20. And the bottom will be negative 9 minus 4, which is negative 13. Now, if you notice, these are all negative here, so here's what we can very easily do. Since everything is negative, we could just negate the numerator and negate the denominator, and all of the negatives will disappear. And the whole thing will be positive. What we really did was factored out a negative 1 from both, and then the negative 1s that we factored out canceled out. So if everything's negative in an expression, you can, in a fractional expression, then you can just change it all to positive. Okay, we are going to do a couple more like this, since this is a new concept. Okay, so first, don't forget about the negative on the outside here. Again, we have i's in the denominator. The only way to get rid of them is to multiply by the conjugate. So we have 9i minus 5. Remember, the conjugate is the same expression, except the constant, the sign of the constant changes. So we have 9i minus 5. Well, look up here. We had 3i plus 2, so we multiplied by 3i minus 2. Now we're starting with the minus. 9i minus 5, we're going to multiply by 9i plus 5. And then we just multiply by the same thing in the numerator, so that the expression stays the same. And now we simplify. Keep the negative out there. Up top, we're going to have 6 times 9i is 54i. 6 times 5 is 30. Negative 2i times 9i is negative 18i squared. And negative 2i times 5 is minus 10i. So all of that over 81i squared plus 45i minus 45i, those are gone. Negative 5 times 5 is negative 25. Now simplify all the I squareds. We'll first simplify the i's up top. 54i minus 10i is 44i. And 30, here we have negative 18 times negative 1, so that's plus 18. 30 plus 18 is 48. Negative 81 minus 25 is negative 106. And don't forget that negative out there. Okay. Now, when you have a negative out here and a negative, the entire numerator or the entire denominator is negative, then these negatives will cancel out. Because what we're doing is dividing by a negative and then multiplying. You're dividing by a negative 1 here and multiplying by a negative 1 here as well. So those are just, they cancel each other out. Okay, let's do just one more. Okay, so with this one, you could factor out the negative from here, make this positive, and stick the negative in front. But in order to make multiplying by the conjugate a little bit harder, we're not going to do that, because here's another way to do this problem. Negative 6 minus 9i. Don't get confused. The 9i is the second term in the expression, but remember, it's always the sign of the constant, the number here that changes. So this will, we multiply by the conjugate instead of negative 9i, and minus 6 will be plus 6 and a negative 9i. So now we just take the numerator and we multiply it by 6 minus 9i. And we're going to do some simplifying. Here we have 6i minus 9i squared plus 24 minus 36i over negative 36 plus 54i minus 54i plus 81i squared. If you do it right, there are no i's left in the denominator. Okay, and last step. It's an I there. Okay, 6i minus 36i is negative 30i. 24 minus negative 9, that's 24 plus 9 plus 33 over negative 81 minus 36. That's going to be negative 107. Now, actually there is one more thing here. When we're dividing by a negative, we can just put that negative out front. But the numerator is going to stay the same. If you like, you can rewrite the numerator like that. Just reverse the order of the term so that you don't have a negative term at the front of the expression. So the reason the negative's out here is we just took it away from the negative 107. Dividing by negative 1, as we are doing here, is the same as multiplying the whole expression by negative 1. So you can stick it out there if you like. It looks a little more, I don't know, professional. Neat. Anyway, okay, that's going to be it for this video. It's getting kind of long. So we're going to continue with imaginary numbers in the next video. I'm going to bring it into how you use them in square roots. So you start to see more of a connection of how this relates to the rest of the unit.